So we started on time here. So a couple of things before we jump into material. Um, we'll kind of start where we left off with the lecture one slides. We will then progress to module two slides, a little bit more than halfway through the class. So today we'll have our first daily quiz. So I wanted to clarify a little bit. So these daily quizzes, do not open them before we cover them in class if you're attending live. So I will kind of prompt you when we're going to start these quizzes. I think I have them set to be about 10 minutes. Usually won't take us that long to cover them. If you're working along with me live, these should be pretty easy points. Or if you're watching it after the fact, I would kind of make sure that when you're watching the YouTube video, you pull up the quiz when we start covering it. Now, given people have different time schedules and commitments, I think I might have misspoke last class. I said they were due the next class. They're actually due before they're due before class the following 2 days. So you'll have about 48 hours if you aren't able to attend live to then watch the recording, the poster recording, and then kind of complete that. So for example, today's won't be due until before we start class on Thursday. So right at 2 p.m. will be that kind of due date. So if you complete it ahead of time, you won't be able to see the correct answers, kind of your responses until after that due date passes. But if you're working along with me, you already have those answers, okay? Module two's reading is a little bit different. Even though we'll start it today, it's not technically due until we start class tomorrow. Typically, these are always due before the class we start covering the material. So for example, module three, once I get that posted on Canvas, that reading will be due before we start class on Thursday, right? Before we start covering module three. It's a little bit different here the first couple of days because we did the syllabus review on day one. And some of the materials kind of cross over multiple days. From here on out, that shouldn't be the case. Okay. Let me think if there's any other things that I want to clarify before we get going. I think that should cover it. Just as a reminder, try to make sure, hopefully you've gotten on, make sure that lockdown browser works for these test quizzes for the upcoming quizzes that cover two modules. So I'll post the first quiz after we get done with class tomorrow. You'll see that kind of pop up here under inflation because it's going to cover module one and module two. Once I post that, you'll have 2 days to kind of complete that. Other than that, I think that should take care of all the housekeeping stuff. My office hours will be kind of as normally scheduled from here on out tomorrow, 9:30 to 11 o'clock in the morning. Otherwise, if there's no other questions, we'll kind of get started where we left off. Okay, so down here, we went through all this last class. Whoops. So we left off kind of looking at this graph. Okay, so start here. We were talking about, we have different measures of the unemployment rate. Generally, it's a pretty good indicator of how healthy the economy is. Unemployment is low. That's a good thing. So we talked about including different types of workers when we were thinking about underemployment. So discouraged workers, how that impacts things, people who are kind of underemployed. And that's kind of where we left off. So another measure that we have that is generally a good indicator of the health of the economy, but it's a little bit more nuanced, is going to be our labor force participation rate. So I'll kind of shorthand this as LFPR. And we'll think about what it does is it actually looks at the percent of our population, and we'll kind of call this our civilian non-institutionalized population. This is going to be anybody over the age of 16. Okay, so anyone that's included in our population over the age of 16, that's going to I'll probably just refer to it as our population, just to not have to say this long terminology. And so when we calculate the labor force participation rate, it's what proportion, and then multiplying it by 100, it's what percent of our population is currently in the labor force. Right? So as a reminder, our labor force is composed of employed individuals and unemployed individuals. We're not thinking about underemployment here. It's just our unemployed plus our employed individuals make up our labor force. So why would lower rates not necessarily be bad if we're looking at that labor force participation rate? Well, if we have our population starts to get older, more of those people are going to retire and not be actively seeking a job. Okay, so let's think about if we have an aging population, what happens is birth rates are also decreasing. And then thinking about if there's fewer people who are able or willing to work, people who are unemployed, or sorry, people who are retiring, how is that going to impact our ratio? So I'll work through an example with some numbers and kind of give you some different scenarios here. So let's start off with, we have a labor force of 1,000, population of 1,500. If we have 250 people age out of the labor force, so they're retiring, okay? So we're assuming they were employed before. We have the same number, everyone else is employed or unemployed, but those 250 people leave the labor force, okay? So we'll kind of work through some examples here, think about what this would look like. So we start out, we have this labor force participation rate, which is our labor force divided by our civilian non-institutionalized population. Okay. I guess also technically, I won't try to trick you or anything with this. Technically, our population would not include people who are like in jail, right? So we started out and our unemployment rate, sorry, not unemployment, our labor force participation rate was our labor force of 1,000 individuals over our population of 1,500. Right? We then multiply it by 100 to get a percentage. This would end up being what? 66.66 repeated percent. So let's assume, kind of that first scenario, we have 250 people. And let's assume for right now they were all employed. In fact, it doesn't really matter if they were employed or unemployed, because once they leave or once they retire, what happens to our labor force? Well, we had 1,000, we now have 750. However, just because they retire, they're still going to be counted in our population, right? So if we have that same population but a lower labor force, right? When we multiply this by 100, we get what? 50% here. So even though our labor force participation rate went down, it's not necessarily a bad thing because these people are no longer able or willing to work. Right? So our labor force participation rate could just reflect that we have an aging population. Okay. Now, what if we had a similar scenario, right? But instead of 250 people retiring, okay, we've got the fact that our birth rates are lower than what they currently were. So in this second scenario, we'll think about, let's say I have 100 people retiring or leaving the workforce, right? They're aging out of that labor force. However, the new workers that I'm getting or that are entering our labor force is 50. Okay. Well, if this is the case, we would have our old labor force. We're losing 100 people, they're retiring, and we would gain 50 from these people who are aging into, right? Now over the age of 16, who are able and willing to work. It doesn't matter if they're employed, unemployed, this is kind of who's leaving that labor force. So my new labor force, right, what's in my numerator here, would be what, 950? However, when we divide that by our population, right, this is still 1,500, right? Those people haven't left, okay? So, this would be a little bit easier. We kind of have this divided by 1,500. Oh, this is going to be off the top of my head. So let me see here real quick. Oh, sorry. So we have what? 950 divided by 1,500. Oh, 950 divided by 1,500. Oh my gosh. 950 divided by 1,500. So multiply that by 100, we get what, 63.33 repeated percent. So we can kind of do it this way. If people are just retiring, right, or they're leaving the labor force, we could kind of see relative to before, our labor force participation rate goes down. Okay. So generally, a lower labor force participation rate is not a good thing. But once again, it could just be that we have people aging out of it. Now, let's think of a third scenario, a little bit different, okay? So let's say I have 100 people not just leave my labor force, This is sad, but let's say they die, right? I then have 50 people kind of aging in and entering. So what would it look like there? And I say die here. Let's also assume this could be from the fact that maybe they leave the country. They go to a different country. Well, under this scenario, my labor force, I lose 100 individuals. I gain 50, but now my population, I'm losing those 100 people entirely. And then I'm also gaining those 50. So now this would be what? 950 over 1450 times 100. There I get a labor force participation rate of approximately 69%. So in this scenario, even though my labor force participation increases, right, it could be because I'm losing individuals, right? That denominator is changing. So this is how you would calculate that labor force participation rate. You need to think carefully about, are the people who are leaving the labor force also leaving my population, or are they remaining? Okay. Excuse me. Any questions on that idea before we keep moving? Okay. Just to kind of, so why didn't number two? So number two, my denominator doesn't change. And it looks like minus here. I meant that's the number, right? Because even though they're leaving the labor market, they're still in my economy. They're still part of my country, right? Here, they not only left the labor force, they're no longer in my population. Okay. So just to kind of check this, what if I had the same scenario, but I had some individuals who are now underemployed? Well, if they're underemployed, they still show up in the employment. My labor force actually wouldn't change, and neither would my population. So if both of these, right, include that underemployment, I actually would have no change in that labor force participation rate. So why don't I add the 50 here? Because those 50 people, even though they're entering the market, they were still part of my population before, right? So maybe it's easier to think about, I have 100 people retiring. I now have 50 people who previously were, I don't know, stay-at-home parents, and they've now decided to take a job. Okay. Any questions? So why don't I add 50? So kind of in this scenario, I guess here, that would be more of scenario 3, where 50 people are aging in, right? So these are 50 people kind of aging. I could change this one to say 100 people retire, 50 people who are younger than 16 now age into it, in which case there my population would actually go up by 50 as well. Okay. Does that help clarify that? So read carefully if we have a question related to this, what those new entrants or those leaving, if they're leaving my economy entirely, right, my population will change. If they were already in that population, but they're just entering the labor market, there the only change I would have is in my numerator. Okay. Any questions over that idea before we keep moving? So here I'll say they enter previously, like you could even think about maybe these were discouraged workers before. Okay. Any questions before we keep moving here? Let's see if I can get it to. All right. So think about a different measure we have of the health of the economy. Oh, there you go. So another way we could think about this labor force participation rate, it's kind of a similar idea. So let's say I just have it, if I look at and I break this down, so let's say the overall labor force participation rate, everyone over 16 is 62%. Well, if we break this down by different age categories, you'll notice some of the younger age categories have lower labor force participation rates because these individuals are in high school or they're attending college. As we start to see individuals get older, more of them enter the labor force. And then when we look at kind of these older categories, 55 and older, people start to retire. Now, all these people are still in our population, our CNIP. However, when they exit that labor force, they start to kind of influence that numerator. Okay? So what happens if we have an increase in the number of people who are 55 years or older? And let's for right now just assume that the number of young individuals we have are relatively constant. Okay. Well, just because they're older than 55, if they're retiring or leaving the labor force, right, we know that that rate's going to be lower. That's going to influence our kind of average labor force participation rate. It's going to pull that average down. Okay. So if I think about just kind of a general equation, so we have that labor force participation rate, which is our labor force divided by that population. As people get older, that's not necessarily changing our population, right? If we don't assume for a second they're not dying, they're just getting older than 55, that population is going to remain constant. However, as they leave the labor force or our population ages, let's assume for example, that birth rates are lower than what what older birth rates were, we're going to have more people leaving the labor force, but still part of our population. So as those older individuals, we have more people in those higher age categories. That's going to decrease our labor force. The numerator is smaller. That decreases our labor force participation ratio or participation rate. Which is typically what we see currently in the United States. I forget what the birth rate is now, but it's less than 2, which means our population is not replacing itself. So we're going to have more individuals joining that 55 and older category than we are going to have people kind of entering into that 16 to 18, 16 to 20, however we kind of define those younger age categories. Okay. Questions on that before we keep moving here? Okay. So another measure we have is the employment population ratio. Oh, there we go. So what this ratio is going to be is we're going to still look at that population, but we want to know what population is not in the labor force, but what ratio, what percentage of that population is employed. Okay. So here, how we calculate this? Very similar to what we were doing before. It's just we're no longer looking at our labor force in the numerator. We're looking at the number of employed individuals in our numerator. Okay. So what happens is population growth is relatively low, and we have more individuals dying than are born. Well, let's assume that employment stays the same and that we just have more individuals leaving our population than are joining it. Well, if most people are not employed, that means as we kind of see population or individuals get older, that'll reduce our population, but it's not going to really change employment by very much because the individuals who are dying, most of them weren't in the labor force. Okay? They weren't employed or unemployed. So if I have that population decreasing because my population is getting older, there we go, that denominator is getting smaller. So if my denominator is smaller, my employment population ratio would go up. So it's a good measure, and then it's telling us it's higher. Generally, that's a good thing for the economy because even if population was constant, as I have more people unemployed, that rate's going to be higher, and that's a good thing. However, just because it's higher, it could mean that my population is just going down. It's not necessarily that I have more employed individuals, it's just that my population is getting lower. Any other questions on that one before I keep moving? So not anything too crazy. Okay. We're now going to think about unemployment and different types that we have. Okay. So the first type of unemployment we're going to think about is what we call frictional unemployment. Okay. So frictional unemployment, frictional, seasonal, structural, and cyclical. We'll now go through them in depth. So my frictional unemployment, is going to be individuals who are between jobs. So even though they're unemployed, it could be because they're holding out, right? And they're searching for better job offers. So they quit their previous job, they're actively searching for a job, they are unemployed, but they expect to find a job relatively soon. They're just not taking the first job available because their skill set, they could find a job that pays more. Okay? So this would be frictional employment. People move back and forth in between jobs. And it's not necessarily because their skill level is lower than what is expected of the kind of current jobs available. It's that they're just waiting to find the best job possible. We would call this short-term unemployment. We don't expect that these individuals stay unemployed for very long. It's just that there's going to be some time in between when they leave their previous job and find a new one. So it could be that even as I increase my education level, I leave my previous job. So maybe I was young and I was working as, at a fast food restaurant while I was in college. Once I have that college degree, I've improved my skill level. I'm not going to remain working at that fast food location. I'm going to look for a job that values my what degree I now have. So that's going to be short-term unemployment. I stop working at this fast food restaurant and I'm on the job market looking for a job where I can kind of use those skills I got in college. Okay. This also could be not just like increasing my skill set, but also maybe I quit or I get fired and even if I'm looking for the same level of job, it just takes some time. Right? We don't expect that maybe I even have an example where my company shut down, right? And even though I want to work in the same field, I just have to transition to another company now. I expect, as long as there's available jobs, I would expect to get a job relatively quickly. I'm just in between jobs. So we would kind of think about this as short-term unemployment. Okay. Now, part of frictional unemployment, we can break this down and we kind of give a separate term to it, which is seasonal unemployment. Okay. So seasonal unemployment is going to be things that are caused by seasonal changes. It doesn't have to be like fall, winter. It could be, different seasons of the area. So I'll give an example here in a second. So a lot of the times it is, it's called seasonal because it is related to am I in the winter? Am I in the summer? There aren't as many agricultural jobs in the dead of winter. There aren't as many snow plowing jobs in the middle of summer. Okay. So even though if I, plow snow and I make enough money to kind of earn an income that I'm okay with for the entire year, I will be unemployed in the summer months, right? But I expect to have that job once it changes seasons, right? Once I end up back into that winter season. So even though I'm unemployed, right? I don't expect that to last forever. It's just until that next season starts. Another example I'll give that isn't as much related to a specific time period, although somewhat is, but I just took a trip up to Michigan, and along the lake, there's a lot of these touristy towns. And if these towns are, tend to be frequented more in the summer, spring, or fall, you know, the restaurants in that area employ more individuals, little kind of, knick-knack stores or kind of where you get your souvenirs, they're going to employ more individuals during those months, but when that area isn't as frequented by tourists, they're going to cut some of those jobs. Those individuals will be unemployed, but they expect to be able to find the same job they had before once people want to visit that area again, right? So once again, seasonal unemployment, very similar to frictional unemployment in the sense that even though I'm unemployed, I expect to find a job, not just when I can find a new availability in the same type of job, but I have that job waiting for me. It's kind of tied to the season. Okay. So what we'll see is a lot of the times when we look at unemployment rates, they tend to be seasonally adjusted. Right? So we'll think about how these seasonally adjusted unemployment rates would vary from our basic unemployment rate. So I've got kind of some sample numbers here. So if I'm thinking about now going back to my unemployment rate, that was the number of unemployed individuals I have over my labor force. Okay. So if I'm thinking about, let's start out with a scenario where, I don't know, I have 3,000 people unemployed and I have 4,000 people in my labor force. Kind of a weird example because unemployment is going to be very high here, but just to make the numbers kind of easy. Right? So this would be what? I've got a 75% unemployment rate. Yikes, right? But let's say I want to seasonally adjust this. Okay. Well, if 3,000 of my individuals are just seasonally unemployed, right? They're kind of being counted in both of these. If I seasonally adjust this, I remove those individuals from my unemployment numbers. But remember, my labor force is the number of employed individuals plus the number of unemployed. If I remove these seasonal workers, I'm actually removing it from both the numerator and the denominator. Now, we talked a little bit last class. My unemployment always has to be less than my labor force. So when I remove the seasonal workers from both, it's going to be a larger percentage of my numerator, right? So it's going to reduce this by a very large amount, but it's a smaller percent of my labor force, so it's only going to reduce this by a little. Even though when my denominator is smaller, this would increase this rate. Because that change in the numerator is even greater, it causes that rate to go down. We can see this using these values. So let's say I have 1,000 workers who are seasonally unemployed, right? So if I have 1,000 workers who are seasonally unemployed, what would my seasonally adjusted unemployment rate be? So if I think about that seasonally adjusted rate, I would take out those 1,000 people from my unemployed individuals. They also get taken out of my unemployed individuals in the denominator, so I'm left with what? 3,000. Once again, we always want to turn this into a percentage, so I now have what? A seasonally adjusted rate that is now lower than it was before. So anytime we adjust for seasonal unemployment, we would always have an unemployment rate that's a little bit lower, right? It's giving a more accurate reflection of who is unemployed or who expects to remain unemployed for longer periods of time, right? Until that, it would reflect individuals who are unemployed but don't expect to have that job waiting for them once that season changes, right? So they are kind of expecting not to be unemployed for longer periods of time. Okay. Any questions on that before we keep moving here? Okay. So the other two types of unemployment that we have, there we go. The first would be structural, right? So structural unemployment is a little bit more of concern, right? Frictional and seasonal, these are people who are expecting to find a job once their current spell is over. Structural unemployment means that I don't have a job and I don't have the proper skill set or the required education level or required skills to quickly find a new job, right? I'm getting kind of left behind. So I always think of like one example of this would be something like, TikTok stars, if that was what my skill was, and then that social media platform becomes less popular, it's not, I don't have a job to pivot to. I'm now unemployed. I can't earn any money kind of with this TikTok account because I haven't updated my skill set, right? I need to maybe, I don't know, find a skill set that matches the newest social media platform. Now, a more accurate or more, I shouldn't say accurate, but a more realistic example would be something like more and more jobs, right? In order to be competitive, I need to have a knowledge of how to use generative AI tools to be more effective at that job. Or maybe it's a level of software understanding to be more effective. A lot of you are Kelly school, all of you are pretty much Kelly students. And so if you don't improve your knowledge of things like R and Python, there aren't going to be as many jobs available that employers are going to take you seriously. So if you don't update your education or your skill levels, you would expect to just remain unemployed. You're not going to match up with any of the jobs that are available. So after recessions, structural unemployment tends to be higher because when I have recessions, there's fewer jobs available. And if I don't update my skill set of the remaining jobs, I'm not able to find a employer that wants to hire me. So when I have structural unemployment, not updating my education or skill set, I'm going to expect to be unemployed for a longer period of time. I might be able to eventually find a job, but it's not as likely because I don't have the education or skill set required to find a job quickly. So we tend to kind of think about, or maybe you'll see it referred to, structural unemployment is like long-term unemployment, as opposed to the other two types we talked about. It's more short-term. So sometimes you'll see today, I put some links up to the things that we're talking about. We may not go through them all in depth, but if you're kind of interested in what the actual numbers look like, I'll post some links up here. So any questions kind of with this idea of structural unemployment? Like I said, the generative AI skill set is probably a little bit more reflective of what we see. You know, the TikTok star was just kind of a dumb, I shouldn't say dumb, but a kind of a trivial example. So the fourth type that we have is going to be what we call, there we go, cyclical unemployment. So cyclical unemployment isn't as concerning as structural unemployment, because structural unemployment reflects the fact that our current population doesn't have the skill set required to match up with the current jobs. Cyclical unemployment just means that as the economy takes some downturns, there's going to be temporarily fewer jobs that are available. But over the course of a year, business cycles kind of go up and down. But if we look over at the, overall at the year and the entire year, the upswings usually are kind of canceled out by downswings. And so that cyclical unemployment, although it might matter week to week, over the course of a year, it's not really going to factor in or not influence our unemployment rate because there's ups and downswings in the business cycle. So really, when we have cyclical unemployment, output of firms is going to be lower, which means they're going to require fewer workers. And we actually see a decrease in the demand they have for workers. Okay? So this decrease in demand means that fewer people are going to be employed, which means subsequently more people are going to be unemployed. Okay? So how is this going to impact, or how does this work? All right. So I'll kind of return to this cyclical unemployment here in a second. But before we do, let's think about the definitions and the differences between full and natural unemployment. So full employment would represent, right, what the level of unemployment is when we have our natural rate of unemployment. So this is kind of a specific definition from the Fed. And this natural unemployment rate doesn't include cyclical unemployment, right? So natural unemployment rate, you can kind of think about if we were to account for or adjust for the fact that we have ups and downs in our economy, what would the natural unemployment rate be if we're looking at a longer time period, right, where they kind of cancel each other out? So natural unemployment is defined as structural unemployment, frictional unemployment, and seasonal unemployment. It doesn't include our cyclical unemployment. If we have any cyclical unemployment, what's going to be true is this natural rate is going to be less than our actual unemployment. Okay? So why is this the case? Okay? So I'll kind of write this out for us here just to kind of make this point a little bit easier to see if I write this out. So we have our natural rate of unemployment includes structural, frictional, and seasonal unemployment. However, the actual rate that's calculated, it's all individuals who are unemployed, so it includes structural, frictional, seasonal, but it also includes cyclical unemployment. Well, as long as cyclical unemployment is anything greater than zero, I'm adding an additional value, the number of unemployed individuals will be larger than the number of unemployed individuals in calculating that natural rate. So this actual unemployment rate will always be larger than the natural rate, right? As long as we have any cyclical unemployment. Okay. Is that hopefully kind of clarifies it a little bit? Any other questions there? Okay. So to kind of round out this discussion, if I do see economic downturns, right, what impacts is this going to have on wages and unemployment? So I'm not sure who you took B251 with. I tend to dive a little bit deeper in the labor market in the course that I teach. Not all professors do. So some of you, this might be kind of a refresher. Some of you, it won't. It'll look a little bit different. Okay? So let's think about if I have economic downturns or economic upswings, good times in our economy, what impact will that have on my natural rate of unemployment and wages? Okay. So if I'm thinking about a labor market, typically when we think about a market for a good, we've got quantity and price. Well, here we're going to think about the quantity of labor or the number of people who are hired, right, or employed. When will people choose to kind of enter that labor market, supply their labor? Well, when they get paid something. So generally, as wages get higher, more people are willing and able to work, right? So our supply of labor is going to be higher when wages are high. Now, who is demanding labor? These are companies. So as the wage is higher, they don't want to hire as many workers. As that wage gets lower and lower, they're willing to hire more workers. Okay. So we've got our supply of labor, looks different than a goods market. That's coming from our workers. The demand for labor is actually coming from our firms. So here is kind of my starting quantity of labor, or I can think about this is the number of people who were employed. This would be kind of that starting wage. If I have an economic downturn, well, if companies aren't producing as much or the goods and services that they are providing aren't worth as much value, they're not going to want to produce as much before, even at the same wage. So at every wage, we're going to see the demand for labor actually decreases. So what's that going to do? It's going to lower overall wages in our economy, and it's going to reduce the number of individuals who are employed. Well, if employment goes down, what's happening to unemployment? It's going up. So when we have economic downturns, we expect to see both wages and the number of employed individuals go down, or wages go down and unemployment goes up. Okay. Any questions on this idea? So, for example, think about everybody in this range wants to work if those wages are higher, but because they're lower, not as many individuals are going to want to supply their labor to those firms, and they'll be unemployed. Now, what if I have improvements in my economy or economic upswings? Well, now companies are going to want to hire more people than they were before. I have an increase in the demand for labor. So during, good times in our economy, wages will be higher and employment levels will go up. Well, if employment levels increase, what is that really saying? That's saying that our unemployment is going down. Okay. So I think that's fairly intuitive that when economic times are good or economic conditions are improving, fewer people are unemployed. When they're deteriorating or we have these downturns in our economy, unemployment is going to go up. Okay. Any questions on that before we keep moving? Okay. So at this point, we've kind of finished lecture 1 slides. I'll then jump into this daily quiz. You can pull it open along with me once we get started here, and kind of work along with me if you're attending this live. Okay. If not, this would be a good time to pull open if you're watching the recording. So just got 2 questions here to kind of go over some things we talked about today, but also to review some of the material from last class. So let's look at an example where if I've got the same number of unemployed individuals, but I have some individuals who are newly employed that weren't searching for jobs before. So maybe these were individuals who used to be staying at home with children. Economic times are good, so wages are higher, so they choose to join that labor force and they're able to find a job. Or it's people who are migrating to a country because the wages there are higher. They're leaving their old country to join this new country because they're able to find a job there or they're becoming employed once they move. So which of the following would not be true in this scenario? Okay. So we'll think about our 4 different measures of employment, unemployment. So if I have my unemployment rate, this was the number of individuals who are unemployed over my labor force. Our underemployment rate is the number of unemployed individuals plus the number of underemployed individuals still over our labor force. We then had, today we talked about our labor force participation rate, which was our labor force over that population, or CNIP. And then we had our employed participation rate, which was the number of employed individuals over that population. Okay. And now all of these are multiplied by 100. Just for the sake of space, I'm leaving that off to kind of compare these. So when we had an increase in employment, but no change in unemployment. So what's going to happen to each of these? Well, if I have newly employed workers, remember our labor force is the employed plus the unemployed. So newly employed is going to increase my denominator, but we said in this example, the number of unemployed individuals remains constant. Remember, this is either people entering the country because they found a job there, or people, leaving, from staying at home because they found a job and are entering that labor force. So they weren't in the labor force before, they now are, and all of them were joining it because they found a job or they are employed. Well, if my denominator is larger, that's going to do what to this overall fraction? It's going to decrease it, right? So under this scenario, unemployment rates should decrease. Now, my underemployment rate, if they're entering, they are not unemployed or underemployed. When they were joining that labor force, right, we should see similarly, the labor force goes up, this rate remains unchanged. So in this scenario, I also see larger denominator. I see a decrease in my, a decrease in my underemployment rate, talking and writing. Then if we have these individuals kind of joining that labor force, we could think of this as my employment goes up, so I have this higher labor force than I did before, right? Now, here's a scenario where it doesn't really matter, right? Because people are joining and they are employed. This could remain the same, right? If this was individuals leaving the house, leaving being a stay-at-home parent to joining that market, my population wouldn't change at all. Now, even if this kind of increases, it's once again kind of the relative size of the increase in my labor force would be larger than the relative size of the increase in my population, because my labor force always has to be less than my population. So if it's easier to think about in this example, we could think about stay-at-home parents entering the labor force. But even if we had people joining our country, that increase in the labor force would always be larger than that increase in our population. So this numerator would kind of dominate, and we see that we'd have an increasing labor force participation rate. Same kind of thing here. If they're all employed, we see an increase in our employment level. Population remains unchanged if they were stay-at-home parents. Even if they're joining our country from another one, this increase would be much smaller as a percent than the increase in our employed individuals, and we would see that employment population ratio also increases. Okay. So if we're looking for which of the following is not true, we said our employment population ratio increases, our labor force participation ratio increases, underemployment rate will decrease, but our unemployment rate will also decrease. So the one that's not true would be the unemployment rate increases. Any questions on this idea before we keep moving? So the other one we have is we're comparing the unemployment rate to the underemployment rate and the natural rate of unemployment to the actual. If we've been paying attention to what we're doing before, this last one should be relatively easy, okay? Because we already said today that when we're comparing that natural rate to the actual rate of unemployment, as long as we have any cyclical unemployment, one person who is cyclically unemployed, the actual rate is greater than the natural rate. Or said differently, I believe the way it was phrased in the problem, the natural rate is going to be less than the actual rate. Now, when we're comparing employment to underemployment, you can kind of see here, if we compare these two, well, my unemployment rate includes unemployed over my labor force. Underemployment has the same unemployed individuals, but it now adds in those who are underemployed. But remember, if I'm underemployed, I still get counted in to the employed individuals. And so my denominator would be the same, but as long as I have one individual who is underemployed, this numerator has to be larger, in which case my unemployment rate always has to be less than my underemployment rate. Okay. So for both of those, we're looking at these. As long as one person is underemployed, and as long as one person is cyclically unemployed, both of these would be less than. The natural rate's less than the actual rate, and my unemployment would be less than my underemployment rate. Okay. So these are what these daily quizzes will typically look like. We'll kind of go through them in class. As long as you're paying any amount of attention, these should be relatively easy questions to answer. Similarly, if you're watching it after the fact, you can have this pulled up as soon as I pull it up in the recording and kind of work along with it. Okay. Getting worried because I haven't had a lot of questions. Any other questions before we kind of transition out of this topic into the next material, which is inflation? Okay. So make sure you're getting this submitted in the next 2 minutes. Once you start these daily quizzes, I typically will have them set to be something like 10 minutes. So once you start, you just need to get it submitted by the end of that remaining time. I should leave more than enough buffer time, so that should be an issue. Okay. Any other questions here? All right, so we're now going to use that module 2 kind of slide deck and PowerPoint. I believe I had it something set a little bit wrong. I fixed it last night, but if any of you were impacted by it, I think I had these slides posted on the homepage, but if you access them through the files page, they were still locked. So I'll make sure that I have them unlocked both under the files and the homepage kind of moving forward, but we should be able to kind of pull these open now. Anybody want to give me confirmation? I can check real quick to make sure, but I believe I had, yeah. So you should have access to those now. All right. So let's dive into the next topic. Okay. So module 2, we're going to be looking at inflation. Okay. So, if this was live, I might spend a little more time to ask a question and wait for a response. But I would expect some of you have heard of or know the term of inflation. And basically all inflation means is that we have an increase in prices. Okay? Everyone complains about it because inflation means that things cost more money. So a good example of this, we'll kind of use just looking at one specific good, which is home prices. I have a link to where I got this data, but here's the image that we're looking at. Well, if we look at 1965 to today, what's happened to average home price sales? They've increased quite a bit. Okay. Now, during some economic downturns, we've seen them maybe decrease a little bit, but on average, home prices are going up, or we have inflation. Okay. Now, here's where I was copying and pasting. I needed to change this, so I'll change this in the posted slides. I had this from the earlier section, so I wanted to leave it, so I reminded myself to change it for you. Oh, no, inflation, sorry. Want inflation here. So if I have inflation or deflation, that is what I wanted, sorry. So I have deflation here. If I have deflation, it's the opposite of inflation. It's a decrease in average prices over time. So I broke this down, or the Census Bureau broke this down into different types of goods. So you'll notice the y-axis here is the percent increase in prices. So anytime I have an increase in prices, that's going to be something that's positive. Anytime I have a decrease in prices, that's going to be a value that's negative. So what types of goods have seen the largest inflation or the largest increase in prices? Unfortunately for you guys, college tuition and fees, right? Daycare is another thing that has dramatically increased over time. And this isn't even a long period of time. This is just since like the year 1997. So we have other types of goods. Most goods and services that we have are all increasing. Their prices are increasing. Now, there are some goods that have remained relatively constant. So new cars and clothing, about the same as what they were in 97. But we have kind of some interesting goods. I don't know why toys has experienced deflation, but they have. But here's things that have had negative changes in price: computer software or accessories. This is likely a result of the technology that's being used to produce these the prices have went down, and so the cost to produce something goes down. I'm willing to sell it at a lower price. I might even have a higher profit margin. It's just that the input prices have fallen quite a bit. Also, televisions, we've seen a pretty large decrease in prices as well. As technology has improved, they become much cheaper to make. And so consumers kind of benefit from this and the fact that prices are dramatically lower than what they were, 25 years ago. So inflation is an increase in average prices. Deflation is a decrease in average prices. Now, another terminology that we're going to have is disinflation. So disinflation occurs if we can still have inflation, but it's inflation that is occurring at decreasing rates, right? So even if average prices are increasing year to year, we could still see that they're increasing at lower rates, right? So if I have kind of an example here from a graph, I'll then break this down into a numerical example for you. What years are experiencing disinflation in the following graph? Okay? So you'll notice here over time, the percentage change in prices, or what inflation, kind of our measure of those change in prices, it's always positive, right? So we have some level of inflation, with the exception of, it looks like in 2009, it just barely went below zero. So this is really the only year where we saw the economy experience deflation. Now, if I look from about 1980 to 1983-ish, notice inflation is still positive. Right? Our inflation rate is still positive over this time period. So we still see that average prices are going up. But year to year, the change in those prices, or the increase in those prices, was less and less, or we had a decrease in our inflation rate. So still positive. We still had inflation over this time period, but the level of inflation was going down. Okay? That would be what we call disinflation. So it looks like here, really on a graph, anytime you see the line going down, even if we still have inflation, if it's going, towards zero, this would be where we also have disinflation. Disinflation, 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 etc. Right? Now, we don't necessarily have a terminology that we're going to use in this class for when inflation is increasing. We would just say that inflation is going up at an increasing rate. Any questions on that before we keep moving here? So I'm now going to give you kind of a numerical example. So this might be something that you see like on a quiz or an exam. So let's say I've got my year. I've got what? We'll just kind of choose random years. So 2000, 2001, 2002, 2003, 2004, 2005, and we'll have kind of a final year here. If I had my inflation rate for these time periods, so let's say this is 3.2, 4.1, 5.3, 2.6, 2.7, negative 1.2, and negative 0.5. So from that graph, I think there were some things that didn't really pop up. So if I was trying to identify here, what time periods did I have inflation? Well, inflation occurs anytime my inflation rate is positive. So in all of these time periods, I had inflation, right? Because that change in my relative price, the change in my average prices, where that inflation rate was above zero. Down here, my inflation rate was negative, which means average prices are decreasing, or I have deflation. Okay? And I'm enunciating this, putting an emphasis on the syllable. It's deflation, but I'm saying deflation to really kind of differentiate these. So when it comes to do I have inflation or deflation, I'm just looking at the sign. Now, what time periods here would I actually see disinflation? So here it gets a little bit tricky. So if I'm looking at this time period, okay, inflation is occurring, it's still going up, but from 2002 to 2003, even though inflation is existing in both time periods, it's getting closer to zero, or it's going down. So this would be a time period in which this economy was seeing disinflation. Inflation was still existed, but it was going down, right? Or it's increasing, it's going up, but it's at a decreasing rate. Okay. Now from 2003 to 2004, it's going back up again. So I don't have disinflation here because inflation rates are now increasing. What about from 2004 to 2005? Well, here, even though I have an inflation and deflation, here I actually see, oh, well, this is kind of weird, but like if disinflation is when inflation rates go down, going from 2.7 to negative 1.2, that would actually be considered disinflation as well, right? My inflation rate is decreasing. Okay. So here we have two time periods of disinflation. What about going from 2005 to 2006? So here's where it can get a little bit tricky. If I have deflation in both time periods, because these are negative values, what's actually happening from 2005 to 2006? Well, my inflation rate is not getting lower because it's a negative value. If it's getting closer to zero, my inflation rate is actually increasing. So I don't have disinflation here. What I would need to have disinflation is something like negative 2.4, right? I don't have a kind of a decreasing rate. That rate is getting even higher. Okay. Any questions on this example here before we keep moving? Okay. So, yeah, on time here. Oh, perfect. So the last kind of topic that we'll cover today is going to be purchasing power. Right? So we'll kind of define it here, and then I'll go through some examples with some numerical examples. So what is purchasing power? It's the number of goods or services I can buy with the same level of income. So if my income stays the same, but I have inflation, so prices are going up, I have the same amount of money in my pocket, I can't buy as many of that good. So my income has less value because I can't buy as much as I was before when I have prices going up or I have inflation. So we would say that purchasing power is going down. Now, what if income increases, but prices do as well? Well, there it matters about what the ratio of income going up is relative to prices. So I've got an example that we'll kind of work through here in a second. But let's just start out thinking about something maybe it's a little bit easier, right? So let's say I start out with this scenario and I've got an income of, once again, we'll kind of keep these values a little bit easier. I've got income of 1,000. And if it helps, generally when we're talking about purchasing power, we're talking about the average price of all goods. But maybe to help just starting out here, we'll think of the price of one good and just what the purchasing power my income has of just this one specific good. Okay. So here, what would my purchasing power be? It's simply my income level divided by average prices, or like I said, you can think of this as the price of one good. So here, what is my purchasing power? Well, I've got $1,000. Every unit costs 100, so I can think about my purchasing power is going to be 10, or I can think about this as I have a quantity that I can purchase of 10 units. Okay. So in these numerical examples, we'll assume that we're spending all of our money on this good. Even if we were to make this like the average price of all goods, people think of, well, what if I have savings? Well, savings is really just buying a good, which is, some financial good, right? Buying mutual funds or buying, these other savings tools. So it really doesn't change what we're doing here. Right? So this was kind of scenario one here that we're starting out with. This was our purchasing power. What if I have the same level of income, right? So income is still 1,000, but now I have inflation. So if I've got inflation, that means that prices have went up. So let's assume that prices are now 200. Okay. Well, my new purchasing power would be I've got the same level of income, but if prices are higher, also, we don't have to have the values. This is a good way to make sure you're not entering numbers into your calculator incorrectly. Well, if income is the same, but prices are higher, well, if my denominator is larger, the overall fraction should go down. So when I calculate this purchasing power, it should be that I can buy less than before. Sure enough, if I do this, I get my purchasing power, or the number of units I could buy, is 5. Okay. So that's what happens if we have inflation. Okay. What if instead I had a scenario where I've got simultaneous changes? Well, before I do that, maybe a different scenario we can think about. What if I had deflation, right? Well, it kind of works the same way, right? In that my income stays the same, but deflation means that prices are going down. Smaller denominator means I would actually see an increase in my purchasing power. So if I do that, example there, let's say income is 1,000, prices go down to 50. My new purchasing power would be what? A quantity of 20. So inflation lowers my purchasing power, deflation increases my purchasing power. So some other kind of scenarios that might be a little bit trickier is, what if I have simultaneous changes in both my price and in my income level? So I think the example I gave you on the slides was, let's say my income goes up, or it doubles. It goes up by a factor of 2. So my new income is 2,000. Prices went up by 400%, or a factor of 4, so my new prices are 400. I'll calculate this first, but then I'll show you a way of thinking about it more in the general formula. So here, if I wanted to calculate my purchasing power, I take my new income, dividing it by my new prices, and I get my purchasing power, or the quantity I can buy of goods and services, is now 5. So if prices are rising more as a percent than my income, right, then I'm going to see my purchasing power goes down. Okay. Now, another way I can think about this in a general context is, if I've got income, and here in our scenario, we said it's doubling, going up by a factor of 2. And this was our purchasing power. Prices were increasing You guys still there? Okay. The computer randomly restarted on me there, so I got back in as quickly as I possibly could. I'm not going to have the slides up. The rest of what the class is going to be was just on the .chem anyways, so we'll kind of keep working through these to finish out class here. I apologize for that. I don't know what the random shutdown was, so hopefully not too many of you left. So we were leaving off kind of thinking about if we had simultaneous changes. Oh, and I'm going to make sure I record this now. Is it still recording? Okay. So if this recording gets messed up, I had an earlier section. I'll just kind of splice in the end to what we covered. But we'll kind of continue where I left off. So I have simultaneous changes in income and prices, right? If that's the case, right, I can go through the numbers and see that my purchasing power went down relative to before. I could also rewrite this and notice my purchasing power, if I do have simultaneous changes, would be the old purchasing power times that ratio of the increase in both income and prices. Or here, what this would be 1/2. So sure enough, my old purchasing power of 10 would now get multiplied by 1/2, or my new purchasing power would be 5. Same thing as if I actually plug the numbers in. So I don't have to necessarily give you the numbers. I could just tell you the factor by which income and prices go up, and you would know what happens to purchasing power. You can think about it this way as well. If my purchasing power is income divided by prices, if my income goes up here, but by a smaller amount, so this is 2, so it's by a smaller amount than the increase in prices. Well, the increase in prices, an increase in my denominator, would cause this fraction to go up. Sorry, cause this fraction to go down. The increase in income would cause that fraction to go up. But because that change in prices was larger, what ends up happening is my purchasing power, this effect dominates, and I actually see a decrease in my purchasing power. Okay. Any questions on this idea before we keep moving around out this example? So what if instead I had a similar scenario, but now I see that income goes up by a factor of 6, or my new income relative to before. So it's now going to be what? 6,000. My prices go up by a factor of 3. So prices are now going to be 300. If I use these values to calculate my purchasing power, I'd have 6,000 over 300, or my new purchasing power, or you can think about this as number of units I can buy, is 20. Even if I didn't know the starting income and price, what do I know has to happen to my purchasing power in this scenario? Well, once again, we can rewrite our purchasing power as our old purchasing power times the relative size of those changes. So in this scenario, I would have my old income divided by my old price, but now it's going to be multiplied by, there was a 6-factor increase in income, 3-factor increase in price. So I know that my old purchasing power will get multiplied by 2, or that my new purchasing power has to be going up. In fact, here you can kind of see my original purchasing power was 10. My new purchasing power is 20, which is larger by a factor of 2. So anytime you have simultaneous changes in income and price, you can plug the numbers in, right? Or you know that it's going to be your old purchasing power multiplied by whatever that relative ratio is of those factor increases. Okay. And I think this is intuitive, right? If my income goes up, but prices go up by even more, my purchasing power goes down. If my income goes up by more than that prices increase, my new purchasing power should be higher than it was before. Now, just to make a point, notice that in both of those scenarios where I have simultaneous changes, I either had that, both income and prices were going up. The same kind of thing would happen if income and prices were going down. So if I have simultaneous changes that are working in the same direction, it kind of becomes a little bit, we can kind of see what's going to happen here. If I have changes that go in opposite directions, just to give you an example of this, let's say income goes down by a factor of 2, but that prices go up by a factor of 2. Okay. Well, here I've got opposite kind of changes here. It should be fairly intuitive what happens. So it's not, when I have going up and down, it wouldn't be that I'm multiplying by 3. I'm actually multiplying by 1/2 when it goes down. So I would think more intuitively about this example. Whereas if I see income and prices working in opposite directions, go back to that purchasing power equation. If I see income is going down and prices are going up, well, lower income is going to cause my purchasing power to go down, and higher prices, that higher denominator is causing it to go down. So if I ever have income and price working in opposite directions, they're both going to have the same influence on my purchasing power. Now, if I actually go through and calculate this, if my income goes down by a factor of 2, instead of 1,000, my new income would be 500. And instead of 100, prices are now getting doubled. This would be over 200. I can kind of see here, oh yeah, my purchasing power fell dramatically because I now not only had a decrease, or sorry, I now not only had an increase in my prices like I did relative to, where was it at? This scenario, I also saw that my income went down, right? So both of those would kind of cause my purchasing power to decrease. So if you ever have simultaneous changes working in opposite directions, you know your purchasing power, you know what's going to happen for sure. If they're ever working in in the same direction, it's going to matter what that ratio is, the relative size of those changes. Okay. Any questions on anything there? I know we got kind of interrupted a little bit, so if you have any questions, feel free to ask them right now since there's a little bit disjoint there. Okay. So let's see here. Before we meet tomorrow, there's the only thing that's to do is to make sure you get on and complete that module 2 reading if you haven't done so already. Once I get back to my office, if you want to get started on that module 3 reading, that'll be due before we start class on Thursday. Wait, what's today? Yeah, Thursday. And then if you weren't attending live and you didn't complete that daily quiz already, you'll need to make sure you do that before we start class on Thursday. Okay. But otherwise, make sure you're getting that module 2 reading done before we start class tomorrow. And if you have any questions, feel free to email me. I will get kind of a response out to you as quickly as possible, and I'll get this recording posted within the next hour.